Hello friends, a very good morning to all the students. Am I audible? Okay, fine. So dear friends, if you remember in the last lecture, we have solved some numericals related to the properties of the gases, and also we have solved one of the important and the master numerical, that was of the spherical balloon. Then friends, if you remember, I had given you a homework to solve some of the numericals for the practice purposes. Let me know in the chat box how many students have solved the numericals and they have got the answers. How many students have solved the numericals and they have got the answers? Okay, roll number 52 has given me the confirmation. Okay, roll number 9 has given me the answer. Roll number 34 has solved. Very good. Roll number 62 has also solved. Okay, 37, 48, 44. Very good. 20, 55. Okay, so a majority of the students. Okay, roll number 9. I have solved all the homework questions. Very good students. Very good. Roll number 59 has also given me the confirmation. Okay, very good students. So now those students who have solved the numericals, they will be guiding me how to proceed further in the numerical and how we will be getting the answers. I will be asking the roll numbers. Those roll numbers only needs to give me the answers in the chat box. And those students who have still not solved the practice numericals, they can mention these steps as I am explaining, and they can note down the answers so that whenever they are solving the numericals, they are aware about the answers. I request all the students to mute themselves. Some of the students have still not muted themselves. Okay friends, so let us start with the first numerical. The first numerical for the homework which I gave it to you, that was determine the work done in compressing 1 kg of air from a volume of 0.15 meter cube at a pressure of 1 bar to a volume of 0.05 meter cube when the compression is isothermal and adiabatic. Take gamma is equal to 1.4. Also comment on your answer. Dear students, this was the numerical which was already asked in the GTU examination. It was asked for 7 marks. So, rule number 5. Kindly give me the given data in the chat box for this numerical. Rule number 5. Kindly give me the given data in the chat box. Very good. V1 is given, that is 0.15 meter cube. Perfect answer. Proceed further. Those students who have calculated, you can just check. I am also repeating the values. Okay, P1 is given, that is 1 bar. So 1 into 10 is to power 5 Pascal. Very good. Converting the bar into Pascal. Proceed further. V2 is given. Very good. Final volume, that is 0.05 meter cube. Perfect answer. Next, what is given? Very good. The value of gamma is given 1.4. Roll number 5, we have just forgot one of the important point in the given data. All the students are requested to off their videos. Some students have started the videos. So kindly maintain the decorum of the lecture. Isothermal process is given, okay, and adiabatic process is also given. But rule number 5, please see the first statement of the numerical. You have not mentioned that point in the given data. I think you have lapsed that point. Okay, M, that is equal to 1 kg. Fine, rule number 5, have you understood? M is equal to 1 kg, which is given in the first statement itself. Okay, very good. So rest all other things are perfectly written from rule number 5. Now, rule number 20. Kindly give me the second step, that is to find. Rule number 20. Kindly give me the second step of to find in the chat box. Okay, rule number 20 has answered. Work done. Okay, we need to find the work done. Very good. For two processes, that is isothermal process and adiabatic process. Very good, student. The perfect answer which I was expecting. Now friends, let us start with the calculations. As you are seeing that in the numerical, we need to find out the work done, but for two cases. In this example, this numerical, we are given two cases. The first case, that is for the isothermal process, and the second case, that is for the adiabatic process. So in case number 1, we are going to find the amount of work done during the isothermal process. And for case number 2, we will find the amount of work done during adiabatic process. And whatever answer we are getting of the work done, that means the positive or the negative values, we will be mentioning the respective comments related to our answer. So now let us start with the calculation. So now I may ask roll number roll number 43. Roll number 43, kindly give me the answer for the equation of work done during the isothermal process. Roll number 43, the equation for work done during the isothermal process. Dear students, kindly know that I will be asking the individual student, they can only respond in the chat box. Rule number 43, I think you are not understanding the point. Okay, rule number 46. Give me the answer of work done for isothermal process, the equation for work done during isothermal process. Okay, roll number 34 has raised the hand. Okay, so can you give me the answer of work done in the chat box for isothermal process, the equation? Roll number 34. Dear students, do not worry. I will be giving the chance to all the students. If you are knowing, that is very good. Rule number 34, the amount of work done. Okay, very good. That is P1 V1 ln V2 by V1. Very good. That is the perfect answer. So work done during the isothermal process can be written as W is equal to P1 V1 ln V2 by V1. As you are seeing that in the given data, we are having all the values. So now we will be substituting the values. So we are getting the answer, that is W is equal to minus 16.48 kilojoule. Since we are getting the negative sign of the answer, the negative sign shows that the work is done on the air during the isothermal process. And this is the first answer of the numerical, that is the amount of work done during isothermal process. W is equal to minus 16.48 kilojoule. How many students have got this answer? How many students? Okay, 2, 3, 4 students have raised the hands. Very good. 5. Some of the students are also responding in the chat box. Very good. Roll number 59 has responded. 26 has given me the confirmation. 66 has also given me the confirmation. Okay, roll number 50 has raised the hand. 23 has also raised the hand. Very good. So majority of the students, even roll number 7 has got the answer. Very good. So now let us proceed further to case number 2. Case number 2, that is for the adiabatic process. So for finding the work done, which value we need to find first in the adiabatic process? For calculating the work done in this numerical, which value we need to find first? Very good students, the perfect answer I have received from majority of the students. Very good, totally impressed by your work. So all the students are giving me the perfect answer. So for calculating the work done in this process, firstly we need to calculate the final pressure, that is P2. And the answer of the final pressure P2 comes out to be 465.5 into 10 raised to power 3 Pascal. So now I can easily use the equation for the work done. So work done during the adiabatic process, W is equal to P1 V1 minus P2 V2 upon gamma minus 1. Now I am having all the values of pressure, volume and gamma, that is constant, already given. So substituting all these values, we are getting the answer. So W is equal to minus 20.68 kilojoule. Again, the negative value shows that the work is done on the air during the adiabatic process. So this is our final answer. Thus the amount of work done during adiabatic process. Okay, some of the students are also giving me their numerical answers in the chat box. Very good. Thank you, students. That means your answers and my answers are matching. That means I have also calculated in the perfect manner. I am also getting the same answers. Okay, thank you all. So I hope majority of the students have calculated this numerical and they are getting the perfect answers. Let us proceed further to the next numerical. So the next numerical tells that a system contains 0.19 meter cube of air at a pressure of 5 bar and 190 degrees Celsius. it is expanded adiabatically until the pressure is 1 bar. The gas is then heated at constant pressure till its enthalpy increases by 100 kilojoule. Determine the total work done. Now my question to all the students, what is the speciality of this numerical? What is the speciality or the characteristic of this numerical? Any student can give me the answer in the chat box. What is the speciality or the characteristic of this numerical? What is special in this numerical which we have observed? Okay, we have to find work for constant pressure and adiabatic. Two processes are taking place. Okay, adiabatic process given, total work done is asked, process is adiabatic till P2, then isobaric, total work done W adiabatic, W isobaric. Okay, so majority of the students, it is just a surprise from the student side. I was not expecting such good answers that you are understanding the numerical perfectly. Majority of the students have understood the logic behind the numerical and they are giving me the perfect answers in the chat box. The important point in this numerical is that in this numerical, two processes are combined. The first process, that is process 1 to 2, that is considered as the adiabatic process, and the second process, that is process 2 to 3, which is considered as the constant pressure process. So if you draw the PV diagram, the logic will be more clear to you. First you need to draw the curve for the adiabatic process, that is labeled as process 1 to 2. Then from point 2, making a horizontal line at constant pressure conditions, the end point, that is 3. So 1 to 2, that is the adiabatic process, and 2 to 3, that is the constant pressure process. And we are asked to determine the total work done. That means we need to find W total. So we will be finding the work done in adiabatic process, and then we will find the work done for the constant pressure process. Individually, we will be finding both the works, and finally for making the total, we will be making the summation of the adiabatic work and the constant pressure process work. So this is the main logic to be understood for this particular numerical. So I am giving you the given data, so you can just check if you have mentioned in your notebooks. Firstly, you are given V1, that is 0.19 meter cube. Then you are given pressure, that is P1 is equal to 5 bar. Converting it into Pascal, so that is 5 into 10 raised to power 5 Pascal. Then you are given temperature T1, that is 190 degrees Celsius. Converting this value into Kelvin. It is then expanded adiabatically. So we are given the adiabatic process, that is process 1 to 2, until the pressure is 1 bar. So at the end of the adiabatic process, the pressure becomes 1 bar. So we are taking the value P2, that is equal to 1 bar, converting this value into Pascal. Then now the second process is started. The gas is then heated at constant pressure. So now new process is considered, that is constant pressure process, till its enthalpy increases by 100 kilojoule. So for constant pressure process, only one value we are having, that is delta H. In delta H, that is equal to 100 kilojoule. Converting this value into joule. So calculating the work done for the adiabatic process using the equation, that is P1 V1 minus P2 V2 upon gamma minus 1. So firstly, for finding the value of V2, we need to calculate the mass. So the mass M, that is equal to 0.7149 kg. How many students have got this answer of mass when you have calculated? Kindly share your responses in the chat box. How many students have got this answer of mass M is equal to 0.7149 kg? Simple equation we have used, P1V1 is equal to MRT1. Since R is not given, we are assuming the characteristic gas constant for air, that is capital R, that is equal to 287 joule per kg Kelvin. Here you need to assume the value of capital R, that is equal to 287 joule per kg Kelvin. Let me know how many students have got this answer of M is equal to 0.7149 kg. Okay, no issue. If you have got the wrong answer, then it is also very good that you will be understanding what is the right procedure to get the answer. Okay, roll number 5 has got the answer. Even roll number 9 has given me the confirmation. Roll number 2 has raised the hand, and roll number 66 has also got the answer. Okay, got the response from roll number 6 as well as the roll number 3. Okay, so they have got the answers for M. Now, dear students, finding the amount of the work done for the case number 1, we are considering case number 1, that is for the adiabatic process, that is process 1 to 2, using the notations 1 to 2. 1 is the initial state, 2 is the final state. So the work done for the adiabatic process, the answer comes out to be 87.625 kilojoule. Make the perfect calculations. Do not be in the hurry to get the answers. Just understand the given data, how we have calculated, what are the values which are given, and then substitute using the appropriate equation for the work done. It's coming 87.75. Okay, there is one instruction, Unnati Parikh, kindly join the group with your roll number format. Unnati Parikh, are you getting my voice? Kindly join the group with your roll number format, standard format. Roll number 54, if you are getting 87.75, that is very near to my answer. That is the perfect answer. Do not worry for that. So let me know how many students has got this answer or near to this answer. Okay, roll number 27 has raised the hand. Roll number 2 has given me the confirmation. Roll number 3 has given me the answer 87.5. Roll number 9 has given me. Okay, roll number 32 is getting some near answer. Roll number 66, very good. Then roll number 50, roll number 20, roll number 66, 59. Okay, so majority of the students are getting the same answer or approximately the near about the answer which I am getting. Okay friends, so since we are getting the positive value of the W, then also you can mention the comment for the W. Now for the constant pressure process, that is process 2 to 3. Here the equation for work done will be P V2 minus V1. So for constant pressure process, The amount of work done during the constant pressure process comes out to be W23, that is equal to 28.52 kilojoules. How I have calculated this equation or the answer I am getting? Firstly, considering the adiabatic process 1 to 2, I have calculated the value of the final temperature, that is T2. I have calculated the value of T2 from the adiabatic process. Then, using the given data for the constant pressure process, I am having the equation, the value for delta H. So delta H is given, that is 100 kilojoule. So the standard equation for delta H is equal to mCp T2 minus T1, that is the final temperature minus the initial temperature. But in my case, in this numerical, the constant pressure process is starting from 2 and ending at 3. So I will be writing down the equation delta H is equal to mCp T3 minus T2. Substituting the values of delta H, M, capital R and T2, I will be getting the answer of T3. Then applying the combined gas law, that is P2 V2 by T2 is equal to P3 V3 by T3. I have calculated the value of V3, and then finally I have used the equation for the work done for the constant pressure process, that is W23, that is equal to P2 delta V, that is the difference of volume. So let me know in the chat box how many students have understood these steps and they are getting the same answer or near about the answer which I have displayed. Okay, 20 has raised the hand, 2 number has raised the hand, 9 number has given me the confirmation. Okay, 32 has understood, 27 has raised the hand. Jay Patel has raised the hand. Okay, 51, I got the near answer. 22 also has got the nearby answer. Very good. Okay, roll number 66 has got the nearby answer. Roll number 27 has got 28.57. Okay, that is perfectly fine. No issue for that. Roll number 17 has got all the answer. Okay, fine. So we have understood this numerical up till this point. Now the next point is very easy to understand. We need to calculate the total work done. So what we will be doing? We will be making the summation of W12 plus W23. Total is the summation of the work done of both the processes. So on making the summation, I am getting the answer, that is 116.145 kilojoule. So this is the final answer which was asked to calculate in this numerical, and since for the total work done we are getting the positive value, so again mentioning the comment, so positive sign shows that the work is done by the air during the process. I hope now the comments are very clear to you how to write down the comments. So the final answer, that is the total work done during the complete process, that is W is equal to 116.145 kilojoule. Dear students, have you understood this numerical? Are you getting all the answers? Kindly give me your responses in the chat box if you have understood and you are getting the answers. Okay, roll number 15 has given me the answer. Roll number 25 has given me the answer. Okay, 51 has also understood. Roll number 5 has also understood. Okay, roll number 2, roll number 27, roll number 37. Are you having any doubts since you have raised the hand? Any doubt from your side related to this numerical? Okay, roll number 54. Can you explain the second process again? Okay, so second process, that is the constant pressure process. That is the process taking from 2 to 3. Initial is 0.2 and final is 0.3. Firstly, using the adiabatic process, I have calculated the final temperature, that is T2. Now using the equation for delta H. So delta H for this process, the second process will become delta H is equal to mCp, final temperature minus the initial temperature. So final temperature will be T3 and initial temperature will be T2. I have been given the value of delta H in the numerical. M I have calculated, capital R I have assumed, and now I have calculated T2. Substituting these values, I will be getting the answer of T3. Now for constant pressure process, I can apply the Charles law. So V2 by T2 is equal to V3 by T3. So I will be getting the answer of V3. And then for the constant pressure process, the W, that is equal to P into delta V. Rule number 54, have you understood these steps? Okay, fine. Thanks for the confirmation. Okay, roll number 2 is asking how the mass is calculated. Dear student, it is very easy to calculate. For mass, it is P1 V1 is equal to mRT1. We are having the value of P1, we are having the value of V1, we are having the value of T1. Capital R we are assuming, that is 287 joule per kg Kelvin. So substituting these values, you will be getting the answer of mass. Rule number 2, have you understood? Okay, fine. So let us proceed further with the third numerical, that was the simplest of all. Can anybody give me in this numerical which process we need to consider? In this numerical, which process we are considering? Kindly give me your answer in the chat box. Okay, got the response from roll number 52, roll number 3, roll number 32, 48, 8, 63, 25, 50, 24. So majority of the students, and rather all the students who has responded in the chat box, all are giving me the same answer, that is the perfect answer. So in this process, we are going to follow the polytropic process. Roll number 66, you have misunderstood one of the point. Dear student, see the equation. PV raised to n is equal to constant. So this is the equation for the polytropic process. Roll number 66, have you understood the point? Okay, fine. So in this process, several parameters we need to calculate. So given data are very easy. V1, that is 0.6 meter cube. Pressure P1 is equal to 1 bar, temperature T1 90 degrees Celsius, the gas is compressed to a volume, so V2 is given 0.18 meter cube. Then we are given the law PV raised to n is equal to constant, so that is polytropic process. The pressure at the end of compression, so P2 is given 5 bar. We need to calculate mass of the gas M, value of index N, the change in the internal energy of the gas, then work done W we need to calculate, the heat received or rejected by the gas during the process. Take gamma is equal to 1.4 and R is equal to 0.294 kilojoule per kg Kelvin. Some of the students have responded me in the chat box by sharing their answers. I have observed those answers. Okay, now I will be displaying my answers which I am getting, so that you can cross check with my answer whether you have got the right answer. So the first parameter we need to calculate, that is the mass of the gas, that is m is equal to 0.5622 kg. Very easy to calculate. P1V1 is equal to mRT1. Okay, roll number 52. So your answer is right. Roll number 34 also you have responded me. So your answer is also right. It is matching with my answer. Roll number 50 has responded 0.564. Very good. So that is also near about the right answer. 63 is getting the answer. Roll number 42 0.5622 kg. Okay. Then roll number 66 0.5643. Okay. So first answer we all are getting the same answer. Let us proceed further in calculating the value of index n. Okay, some of the students are responding me in the chat box about the value of n. Okay, so let me first see your answers, then I will display my answer. Okay, some of the students have started responding me 1.33, 1.34. Okay, 1.33, 1.34. Okay, you can keep the answer up to the 2 decimals, no issue. Roll number 42, I think your answer is somewhat incorrect. So just check your calculations. Roll number 42, just check your calculations because your answer is differing. Very good. So majority of the students are getting approximately the near about answers. So the answer which I am getting, that is n is equal to 1.3378. So I have approximated that value, that is 1.34. Okay, so you can use 1.33, but since it is 78, so I have approximated the term, that is 1.34. Okay, so now the next all other answers will be dependent on your value of n. If you are using small n 1.33, your answer will come somewhat different. And if you are using n is equal to 1.34, your answer will come some different. So I have calculated the remaining values considering n is equal to 1.34. Okay, students. So let us proceed further. Change in internal energy delta U, that is equal to 75.75 kilojoule. Let me know how many students are getting this answer or near about the answer. Roll number 2, kindly lower your hand. Sir, I have used, so U is equal to 74.6852. No issue, you are getting the same answer. Near about the answer, so do not worry. Okay, 74.87, that is also correct. No issue for that. Before calculating only, I just cleared that if you are using 1.33, you will be getting some another value. If you are using 1.34, you will be getting some another value. So next answer, that is amount of work done, that is W is equal to minus 88.23 kilojoule. And the final answer, that is the amount of heat transfer, Q is equal to minus 13.2345 kilojoule. Okay, dear students, so from next lecture, we are going to start one of the important chapter, that is Unit 5, chapter number 5, that is heat engines.